In this video, we are going to see Module 5 Multimedia Networking. So, what is a multimedia? If I can communicate my information through multiple format, then we can call it as multimedia. The networking information related to multimedia is nothing but multimedia networking. How can we send the multimedia data through the networks? This is what we are going to see in this module. Okay, shall we get into the topic? Yes. The first topic under multimedia networking is multimedia networking applications. So if you see the multimedia networking applications, under this we have multimedia audio. So as you all know, the multimedia audio, as I said, the data can be sent in different formats, that multiple formats. What are those multiple formats? The first one is text, then images, audio, video. These are the multiple formats through which we can communicate the data to the receivers or to the destination. Since it can be represented through multiple format, we will call it as multimedia. Through in the medium, we can send different formats or multiple formats through the media. That's why it is called as multimedia in the networks. Okay, so the first format we are going to see is audio format of data. How the audio is available? It is in the form of analog audio signals. Okay, analog signal. The audio is always, the sound is always represented in the form of analog audio signals. Okay, but through the network we can send in the form of digital data. So how can we convert this analog audio signal to the digital data? So if you take telephone voices, telephone audio, how the data is converted to digital data. If you take CD music, how it is converted, that's what we are going to see. So we have two processes involved in converting the analog audio signal to the digital data. The first process is sampling, in which the analog audio signal will be converted into the real values. Okay, real number values. Then this will be quantized. This process is called sampling. The first process that it has to undergo is sampling. After that, the quantization is done, with which we'll be converting it into finite values. Real number values will be converted to real number. From there, this finite values will be converted into the bytes. See, for every sample, it will be converted into a byte. That is 8 bits of data, which is represented in zeros and ones. So these two processes involved in the conversion of the analog audio signal to the digital data. One is sampling, the other one is quantization. This topic is available at the Data Communication Bureau's Ferozon. So I'm just saying the steps involved in it. Already you would have studied in data communication in the last semester. So I'm briefing that only two processes are involved. One is sampling and the quantization. Okay. So finally, after the quantization, the output will be zeros and ones. For every sample, we'll be getting 1 byte of data. Yes. Next, multimedia audio, as I said, 8000 samples per second is quantized to 256 quantized values, which is again converted to 64. After sampling, we'll get this 256 quantized value. After quantization, we'll be getting 64,000 bits per second. Okay. Next, again at the receiver, this is done at the sender. What should be done at the receiver when receiving the data? Again, it has to be, digital data should be converted to the analog audio signal. So again, the decoding, that is the same process should be repeated. Next format of data is video format. So what is video? If you take a video, it is nothing but a sequence of image. If the sequence or a collection of the images are displayed at the constant rate, then a video will be formed. Okay, we can see that data in the form of video. So for example, if you take 24 images per second, if you can display in sequence all the 24 images per second, it will be reproduced as the video. So digital image can be represented as with the help of the array of pixels, each pixel represented by bits. Yes. Then here coding is done. Why do we need coding? Since the size of the video data is high, it should be compressed to send through the network. If we send the data as such through the network, it will occupy, or it requires more bandwidth, which is not affordable. So we have to compress the data, compress the video data and send through the network to reduce the bandwidth. So how can we compress the data? There are two ways to compress. One is spatial encoding and the other one is temporal encoding. Spatial encoding is done within the image and the temporal encoding is done from one image to the next. So we'll see what is spatial encoding. Yes, instead of sending n values of same color, here they are selecting an image, and see the violet color you are seeing in this diagram is occupying almost the 75% of the image. So no need to represent in all the pixels the same data. So what we can do, how many times that color should be repeated in the image. We have to give only two parameters, the color and how many times the same color should be repeated in that image. If you give that, that is enough. That is why it is called spatial coding. It is done only within the image. Okay, no need to represent that the first pixel is violet color, again the second pixel is also violet, third pixel, no need to do that. Okay, instead, so for how many times the same color is repeated, just color and how many times it should be repeated. If you give that, that is enough. Clear. So this is how the compression is done using the spatial encoding. If you take temporal encoding, here we are going to, as I said, if you take a frame, I said a video is nothing but the sequence of images. So it is not necessary to send all the 24 images through the network. Instead, whatever the difference between the first frame and the second frame, that is, if that is done, that is enough. That is called temporal encoding. No need to send all 24 images. Take the first frame, frame 1. So you have to see the difference between the frame 1 and the frame 2. There would be minute changes between frame 1 and 2. So only that difference or changes should be taken and that should be sent. No need to send the both images. Clear? So the only change is required. Only change or difference between the two images is required. It is not required to send the entire second frame. And if you take third frame, whatever is the difference between second and the third frame, only that should be sent. Like hand movement. So hand will be moved from the position 2,3 to 3,3 in third image. So only that difference can be sent. No need to send the entire image. So this is how we are decompressing the data and sending through the network. Okay, instead of sending all the 24 images, just send the difference between every image. That's enough. That is called temporal encoding. Yes. See, temporal encoding, instead of sending complete frame at i+1, send only the difference frame from frame I. That's what said here. Yes. So multimedia video can be encoded in two different types, that is constant bitrate and one is variable bitrate. So if it is going to be the rate at which the encoding is done is fixed, then it is called constant bit rating. If it is variable, then it is called variable bitrate, that is changed. Then comes three application types of multimedia networking. The first one is streaming stored audio and video. This is quite interesting topic which we are seeing in our day-to-day life. Yes. So if you take YouTube, there how the data is represented to us. Already the video whichever we are watching is saved in the server, the YouTube server. So the audio and the video which we are seeing from the YouTube is the stored one. So whenever we want to see the video, we can open the YouTube and just we can play out. So the data will be received from the server. So it is streaming stored audio. This is the best example. YouTube is the best example to get the data from the stored server. So streaming can begin play out before downloading entire file. There is no need to download the entire file. You just open it, play. That's it. Then it is stored at server. Yes, I can transmit faster than the audio and the video will be rendered. So since it is already recorded and stored, the processing time is less and we can see it faster. Transmission will be faster. Next type is conversational voice or video over IP. So this is what we are doing in our like after COVID we are doing. So the Google Meet, Zoom and all. What we are doing, conversational Zoom meeting and all happens, right? That is conversational voice and video. We can send over IP. So whatever is sent, it is not stored anywhere. It happens live, and both the sender and the receiver are, or the people who are all in the group or who are all in the meeting are communicating, and that is transmitted between the people who are there in the entire group. So it is conversational voice or video over IP. The best another best example is Skype, and we have WhatsApp voice call, video call. These are the examples of conversational voice or video over IP. Next is, yes, conversational. This is interactive nature of human to human conversation. Limits delay tolerance. Yes, it can tolerate some delay. Next comes streaming. The third application is streaming live audio video. So where can you find this? Actually, if at all we are seeing cricket matches live, so that is the best example of streaming live video audio, where it is recorded and transmitted through the network simultaneously. Recording and the transmission takes simultaneously. Then it is called streaming live audio and video. The first one was streaming stored audio and video. What we are going to stream in the channel, whichever is stored in the server. The second one is conversational. We are not storing or saving any data in the server. Here whatever happens, whatever the conversation happens, that is streamed. And the last one is, it is streaming live audio. Whenever it is recording, simultaneously it is streamed. Like finale, some program that happens in the television also, sometimes it would be live. Those are all called streaming live audio video. Those are the best examples of streaming live audio and video. So with this we are completing this topic. Hope you would have understand. Thank you for watching.